Okay, so question 2. This one is a question that's based about log laws. So we've got these expressions here for a couple of logs. We've got P, we've got Q, and we've got R. And we're asked to express each of these in terms of P, Q, and R. So first of all, ln6. Now we don't have ln6 here, but what we do know is that 6 can be written as the product of 3 and 2. So we'll write that out real quick. ln 2 times 3. Now, if you're familiar with your log laws, you will know that that is the same thing as ln 2 plus ln 3, because the product on the inside results in the addition of logs. If we have a look at our terms up here, we can see that that is equal to this one here, P, plus this one here, Q. All right, second question. This one's a little bit trickier. We've got the natural log of 6.25. Now, it's not entirely obvious, but 6.25 is actually equal to this fraction here, 25 divided by 4. Now, if we take 25 divided by 4, we know that that's the same thing as ln 5 squared divided by 2 squared. Now we're going to separate out that, so we know the division of logs right here means subtract the logs, so we're going to end up with ln 5 squared minus ln 2 squared. Now we also know, because of our exponential log laws, these powers can be written out the front of the log. So we're going to end up with 2 ln 5 minus 2 ln 2. Now if we have a look at what that corresponds to up here, that is going to end up being 2 times r minus, and this one here is going to be p, 2 times p. All right, second question, we are asked to calculate the definite integral of this thing right here, the derivative of ln x. Now, we know from the fundamental theorem of calculus that when we have the derivative and we're integrating it, then these two things cancel each other out. So what we're going to end up here is ln x evaluated from 3 to 2. So we're simply bringing this down here. So we know that when we evaluate that integral, that is going to be the same as ln 3 minus ln 2. Check for what that equals up here. We are going to end up with q subtract p. Now we're asked for e to the p plus q. So that is going to be e to the ln 2 plus ln of 3. Now we know that that is the same thing as e to the ln 6 by log laws, and we know that these two functions cancel each other out because they're opposites, e and ln, so that is just going to be equal to 6. Okay, now we're asked to calculate the derivative of x ln x. So again, this is another product rule. We're going to do the derivative of x times by ln x, then the derivative of ln x times by x. So we'll write that out. X times by ln x plus the derivative of ln x times by x. So if we do that, we see that the derivative of x is just 1 times by ln x. Now the derivative of ln x, we know that that is 1 divided by x times x. These things cancel. We end up with ln x plus 1. Okay, this is a tricky one that I'm sure a lot of people would mess up on. we've got the integral of this thing equaling that. Now, if we take our result from up here, we end up with the equation, the derivative of x ln x equals to ln x plus 1. Now notice, if we take the integral of both sides, we're going to get an expression that involves the integral of this ln x term right here. So let's do that. We're going to go integral of the derivative of x ln x dx equals the integral of ln x plus 1. Okay, so we're going to evaluate this. Now this one is the integral of a derivative, so we know from the fundamental theorem of calculus we can cancel these things out, and we're going to be left with, we're going to be left with x ln x. Now this one we don't actually know the derivative of ln x, so we're going to leave that ln x dx. And this one we know the derivative of 1 is, so the integral of 1 is x plus c constant of integration. We're going to move these terms over here to the other side, and we're going to be left with this expression, x ln x minus x plus c. Now it would be minus c, but since c is a constant of integration and can be anything, it doesn't really matter if we have plus c or minus c, so we're going to leave it as plus c, equals the integral of ln x. And if you look carefully, this is the exact same expression that we were asked to show up here. So that is the solution to this problem. Okay, now we are asked to evaluate that integral between 3 and 1. So we have from here our expression. Now we are just going to plug in 3 and 1 from there. So we've got x ln x minus x from 3 to 1. That's the same thing as 3 times ln 3 minus 3 minus the entire expression of 1 times ln 1 minus 1. Okay, so when we evaluate that, we're going to end up with 3 ln 3 minus 3 minus, now ln 1 is 0, so that term is going to disappear, minus minus 1, that is going to be plus 1. So we end up with 3 ln 3 minus 2. We're asked to leave that in terms of PR and Q, so we see that Q is ln 3, so we can just say that that is 3 times Q minus 2. That is that question.
Thank you for watching. My name is Henry, part of a team at Elucidate, a non-profit organisation that helps young people succeed at school. If you would like to see more chemistry videos, click up here. If you would like to learn more about us or support us, click down here.